Hello, Sleepy Science subscribers. Welcome back to the channel tonight, and thank you for being here. Before we begin, remember to subscribe and leave a like so more people can relax and drift into calm sleep with us. And I'm truly curious, as always, about where you are watching from and what time it is for you right now. So feel free to share it in the comments. Your messages float through this space beautifully and help soften our little community under the quiet horizon we build together. Now, let us move into tonight's gentle story, guided by dim light and deeper calm. Deep inside the fabric of the universe lies a question older than galaxies, older than stars, older even than time as we understand it. What is the smallest piece of everything? What lies beneath atoms, beneath the particles that form the air we breathe and the light we see? As we drift slowly into this question, the universe feels like a vast ocean of possibilities, where the smallest ripples move with gentle waves that originate from places too tiny to imagine. For thousands of years, humans believed atoms were the smallest building blocks. They seemed indivisible, complete, perfect. But when physics softened the boundaries of classical thinking, when scientists allowed their imagination to float freely, a deeper world revealed itself beneath the atom. A world wrapped in dim light, shaped by rules that do not behave the way ordinary objects do. In this space, particles do not sit still. They drift, they flicker, they appear and vanish, moving like tiny sparks caught between existence and silence. Inside the nucleus of an atom, we find protons and neutrons, and even inside those lie quarks, bound together by the strong force. Quarks are incredibly small, so small that describing their size feels almost impossible. They do not exist as isolated objects. Instead, they float inside protons and neutrons, held by gluons, particles that act like threads of pure energy. The behavior of quarks does not follow the calm logic of everyday experience. Instead, they move in restless vibrations, wrapped in a haze of quantum uncertainty, like tiny storms hidden beneath a quiet horizon. Even deeper, physicists have suggested something more subtle, more mysterious: strings. According to string theory, the smallest units of reality are not particles, but vibrating strands of energy. Each vibration creates what we perceive as a particle, much like different notes emerging from the same string of an instrument. These strings, if they exist, would be smaller than anything we can detect, drifting through dimensions we cannot see, floating under layers of space folded in ways the mind struggles to picture. Their scale is so tiny that even the most powerful microscope would reveal only darkness, a dim light barely whispering that something lives beneath. At such small scales, the universe no longer feels solid. It softens into a haze of probabilities. A particle can be in many places at once, can drift through barriers, float across distances instantly, and behave as if it is both a wave and a point in space. Everything becomes blurred, smooth, delicate, like gentle waves forming at the edge of a cosmic shore. In this deeper calm, matter no longer acts like matter. It becomes pure possibility, rippling patterns, vibrations that dance without ever truly resting. Some theories suggest that space itself is made of tiny units, as if reality has a smallest pixel or grain. These space-time quanta would shape the structure of the universe on scales so small that our concepts of distance and direction fade into silence. If space has a smallest possible piece, then even emptiness has a texture, a soft network of trembling nodes that drift beneath all things. So what is the smallest part of the universe? A quark? A string? A vibration of space-time? The truth may be more fluid, more dreamlike than any single answer. The smallest piece is not just a particle. It is a behavior, a rhythm, a pattern of existence moving quietly beneath everything we see. It is the universe whispering in its tiniest voice, wrapped in dim light and drifting through deeper calm. When we look deeper into the quantum world, the scale becomes so small that even language begins to lose its shape. At these tiny distances, objects do not behave like pebbles or dust or even molecules. Instead, they behave like whispers of energy, drifting in and out of focus. Quarks vibrate inside protons and neutrons with restless motion, bound by gluons that pull them together with unimaginable strength. These gluons do not simply hold particles. They create a sea of shifting fields that float through the nucleus like subtle tides beneath dim light. Physicists describe this restless interior using the theory of quantum chromodynamics. The idea is simple in words yet profound in depth. Quarks carry a color charge, and gluons mediate the force between them. But in practice, this force behaves like nothing else in the universe. Instead of weakening with distance, it strengthens. If you try to pull one quark away from another, the energy between them rises like a stretching spring. Eventually, the tension becomes so immense that it pulls new quarks into existence. Even empty space softens and cracks open, producing new particles from the fabric of the vacuum itself. It is a reminder that the quiet horizon of matter hides a storm of activity too small for the eye, but too powerful to ignore. Yet even quarks might not be the final answer. Some scientists believe there may be layers beneath them, patterns more fundamental, vibrating with a precision that defines the identity of everything in the cosmos. According to string theory, particles are not points but loops or strands of energy. These strings drift and vibrate across dimensions, curled so tightly that they evade detection. Their smallest movements determine whether a particle becomes a quark, an electron, a photon, or something else entirely. The universe, in this view, is a symphony of vibrations, each note forming the matter and forces we observe. Imagine these strings floating within a space that itself may be quantized. If space-time has a smallest unit, something like a grain or pixel, then even emptiness is structured. It would be as if the universe were woven from a delicate tapestry of tiny fibers, each one vibrating under the dim light of the quantum world. The smallest motions in these fibers would ripple outward like gentle waves, shaping everything from the behavior of atoms to the expansion of galaxies. In this hazy frontier, uncertainty becomes the rule. A particle does not exist in a single place but spreads out like a soft cloud of possibilities. It may drift through two paths at once, float through barriers, or appear in a spot it never seemed to approach. This is not a glitch in our understanding. It is the nature of reality at its smallest scale. The closer we look, the more matter dissolves into patterns of energy, probability, and vibration. Some researchers even propose that the smallest building block of the universe is not a particle or a string, but information itself. They suggest that reality may be encoded as tiny bits, yes or no, here or not here, woven into the structure of spacetime. In this perspective, particles arise as patterns in an informational sea, like waves forming on a silent ocean under a quiet horizon. These waves drift and soften into existence, shifting between states as they interact with the wider universe. So while we search for the smallest piece, the universe quietly reminds us that smallest may not mean solid or simple. It may mean fleeting, fuzzy, dreamlike, a rhythm rather than a thing. The deeper we explore, the more the quantum world invites us into a space of deeper calm where the tiniest entities float between being and not being, shaped by rules that bend like gentle waves flowing through the night. And as we continue our journey, the question itself begins to glow with new meaning. When we explore the smallest scale of reality, we discover that emptiness is never truly empty. Even what we call vacuum is restless. It flickers, It breathes with invisible energy. Particles and antiparticles appear for a moment, drift into existence, and then vanish again before they can be fully noticed. These fleeting visitors are called virtual particles, and they fill every corner of the universe, even the space between atoms, even the depths of what seems completely silent. Under this dim light of quantum behavior, emptiness softens into a living fabric that floats beneath everything. At these unimaginably small scales, something profound happens. The classical rules we know melt away. The universe becomes granular. Time becomes uncertain. Space behaves like a shimmering haze. Particles no longer travel in straight lines, but drift like tiny clouds, spreading and collapsing according to invisible waves of probability. This behavior is described by the wave function, a mathematical whisper that predicts where a particle might be rather than where it is. It's a reminder that in the realm of the very small, certainty dissolves into deeper calm, and reality becomes a soft blend of possibilities. Consider the electron, one of the most familiar subatomic particles. Despite its importance, it is not a small sphere or dot. It is a field excitation, a ripple that floats across space. It has no physical size in the traditional sense. Instead, it exists as a region of influence, a pattern of behavior. When an electron appears around an atom, it forms a cloud-like presence, drifting around the nucleus in shapes that resemble petals, spheres, or rings. These shapes are not paths the electron travels, but probabilities of where it might be found if observed. Closer to the nucleus, quarks and gluons interact in a chaotic but beautifully coordinated dance. Gluons bind quarks together with a strength that increases over distance. This strange feature creates confinement, the reason quarks are never found alone. If you try to tear them apart, the force between them stretches like a tightened rope until it snaps, creating two new particles. It's as though the universe refuses to expose its smallest secrets directly, choosing instead to let them float in pairs and groups beneath a quiet horizon of invisible energy. But even quarks and electrons might not be the end of the story. Many theories propose entities even smaller, Planck scale structures that sit at the foundation of reality. At the Planck length, space may no longer be smooth, but instead grainy and pixel-like. Physical distance becomes quantized. Time itself may move in discrete steps, not continuous flow. If this is true, the universe is built from tiny units of space-time, vibrating nodes that drift and soften like the threads of a cosmic fabric. Some physicists envision these nodes as loops of energy, forming the basis of space through a framework called loop quantum gravity. Instead of particles moving through space, space itself becomes a network of connected loops, woven together in silent patterns. These loops are unimaginably small, far smaller than any quark, far beyond the reach of any experiment. They float beneath existence like the faint heartbeat of the cosmos. And there is an even more mind-stretching possibility that the universe is holographic. In this view, everything we experience as three-dimensional emerges from information, encoded on a distant surface. Reality then becomes a projection, a soft illusion woven from data. The smallest pieces are not particles, but bits of encoded information drifting along the edges of space and time. So what truly is the smallest part of the universe? A quark? A vibrating string? A loop in space-time? A flicker of information? Perhaps each possibility is correct in its own domain, like layers of a dream unfolding one beneath the other. What we know for certain is this: the deeper we look, the more the universe softens into mystery. The smaller the scale, the more reality drifts into a haze of probability and vibration. And the closer we get to the smallest piece, the more the cosmos reveals itself as a calm ocean of hidden rhythms, moving with gentle waves beneath the quiet horizon of existence. As we drift deeper into the microscopic frontier, we encounter a landscape where intuition fades, and the universe reshapes itself into patterns both delicate and profound. At these scales, nothing stands still. Every particle floats between states, every field vibrates softly with energy, and every moment unfolds in a realm where certainty dissolves like mist under dim light. The search for the smallest building block becomes less like examining objects and more like listening to the subtle rhythm of reality itself. Quantum fields fill all of space. They extend across the entire universe, forming invisible oceans of potential. Particles, in this view, are not solid bits of matter but tiny disturbances, ripples that rise from these fields when enough energy gathers in one place. An electron is a ripple in the electron field. A photon is a ripple in the electromagnetic field. These ripples drift through the fabric of space like gentle waves moving across a quiet horizon. When the ripple fades, the particle vanishes, yet the field remains everywhere, silent and waiting. Because of this, many physicists say the universe has no smallest piece in the traditional sense. Instead, everything emerges from fields that float beneath existence. But even these fields may have structure at the tiniest scale. Some theories suggest that space itself is made of discrete units, tiny grains of volume no larger than the Planck length. These grains are unimaginably small, far beyond the reach of any microscope or particle accelerator. If this is true, then space is not smooth, but pixelated. A soft lattice of points through which energy drifts and particles flicker in and out of being. In this picture, time may also come in tiny steps, each moment distinct, like frames of a cosmic film. Between these steps, reality unfolds in quantum leaps, not continuous flows. What we perceive as motion may be the gentle stitching of countless tiny intervals, woven together into the illusion of smoothness. These ideas soften the boundaries of what we think space and time truly are, inviting us into a deeper calm, where the universe becomes a dance between discreteness and continuity. Some scientists propose an even more dreamlike structure beneath everything: vibrating strings of energy. These strings are not particles but one-dimensional strands that vibrate with different frequencies. A low vibration might create a quark, while a higher vibration might create a photon or electron. In this view, the entire universe is music, each object, each force, each particle a note in a grand symphony. These strings float through multiple dimensions, some curled tightly like hidden corridors. Though invisible, they may be the foundation that all matter and energy drift upon. And beyond strings, there are ideas like the holographic principle. This theory suggests that everything we experience in 3 dimensions may be encoded as information on a distant cosmic boundary. Space, particles, even ourselves would then be projections, soft images cast from a deeper layer of reality. In this sense, the smallest unit would not be a particle or a loop of energy, but a bit of encoded information. Reality becomes a tapestry woven from symbols, drifting through time with gentle waves of meaning. Virtual particles continue to flicker through the vacuum, forming pairs that appear and vanish in moments too short to measure. These flickers are like the breath of the quantum world, a quiet reminder that even emptiness is alive with motion. The smallest building blocks may lie hidden in these fluctuations, tiny bursts of energy that soften the boundaries between existence and non-existence. So when we ask, what is the smallest part of the universe? The answer becomes layered. Perhaps it is a quark, perhaps a vibrating string, perhaps a grain of space-time, perhaps a quantum of information, or perhaps the true answer does not exist as a single thing at all. The deeper we look, the more reality floats into abstraction. The smaller the scale, the more the universe drifts into patterns that behave less like objects and more like whispers, soft, fleeting, wrapped in dim light, moving in deeper calm beneath the quiet horizon of the cosmic fabric. As we continue drifting downward into the hidden layers of existence, the scale becomes so small that ordinary descriptions no longer fit. The universe shifts from something built of tiny pieces to something woven from fields, vibrations, and possibilities. At this level, reality feels softer, less rigid, as if the borders between here and not here float like mist across a quiet horizon. The question of the smallest piece becomes both simpler and more mysterious. We may not be searching for an object at all, but for a behavior, a rhythm, a fundamental pattern that shapes everything above it. Quantum mechanics reveals that particles behave not like marbles or grains, but like waves. Even the most familiar particles, electrons, photons, quarks, do not occupy a single point. Instead, they spread out across space in soft patterns of probability. Their position is never fixed until measured. They drift through multiple possible locations, float across invisible fields, and exist in a haze that resembles a gentle wave rolling beneath dim light. As we go smaller, that haze becomes the central truth. Matter dissolves into uncertainty, softened by the strange laws that govern the quantum world. Yet the smallest components we know, quarks and leptons, behave as if they are indivisible. In the standard model of particle physics, they are treated as point-like with no internal structure. But their point-like nature does not mean they are simple. Each one interacts through fields that ripple across the universe. Quarks respond to the strong force, a force so intense that it traps them together. Leptons, like electrons, interact through the electromagnetic field. Neutrinos, almost ghost-like, drift through matter unnoticed. Each particle carries with it a distinct signature, a vibration in its respective field, like a quiet note played in the cosmic orchestra. But even here, at these unimaginably tiny scales, the question continues to soften. Are these particles truly the smallest, or do they conceal yet another layer beneath them? Some theories suggest preons, hypothetical objects even smaller than quarks. Others propose strings, tiny loops of energy vibrating in higher dimensions. In string theory, the smallest unit is not a particle but a vibration. The universe becomes a musical instrument, with each fundamental tone creating a different type of matter. These strings float in dimensions curled so tightly that they cannot be seen, their motion shaping reality from the shadows. Beyond strings lies another possibility, that the universe is discrete at the Planck scale. According to this idea, space and time themselves are made of tiny units, Planck length for distance, Planck time for duration. Nothing can be smaller. Below these scales, the concepts of location and moment dissolve. Space-time becomes pixel-like, a woven fabric of tiny vibrating nodes. Reality becomes geometric, granular, threaded with loops that drift and twist in patterns too small to detect. If this is true, the universe is not infinitely divisible, but built from the smallest possible grains of existence. Even more dreamlike is the idea that the smallest unit of reality might be information. According to the holographic principle, everything inside the universe may be encoded on a distant boundary, much like a vast cosmic screen. Matter, energy, and space would be projections of this encoded information, drifting into three-dimensional form. If so, the fundamental building block is not a particle or a string or a loop. It is universe. The cosmos becomes a whisper written in light, floating across dimensions we cannot see. All of these possibilities illuminate one truth. The deeper we dive, the more reality drifts into mystery. The smallest pieces act less like solid objects and more like shimmering behaviors, interactions, and vibrations. What lies beneath everything is subtle, soft, hidden beneath the dim light of the quantum frontier. Perhaps the smallest part of the universe is not something we can touch or see, but something we can only describe, A flicker of energy, a ripple in a field, a vibration echoing across unseen dimensions, a gentle wave drifting beneath a quiet horizon. In this deeper calm, the universe becomes more than a collection of parts. It becomes a living pattern, woven from whispers so small they blur into a dream. As we move further into this silent frontier, the question, what is the smallest part of the universe, begins to unfold like a soft veil lifting under dim light. With every layer we peel back, the structure of reality becomes less like a solid sculpture and more like a trembling melody, subtle, fluid, shaped by unseen rhythms. Particles no longer appear as tiny beads, but as behaviors, responses, vibrations drifting through deeper calm. Even the vacuum, which once seemed like pure emptiness, reveals itself as a restless sea. Quantum fluctuations stir constantly beneath the surface. Virtual particles emerge and vanish, floating for the briefest flashes of time before returning to silence. They do not exist in the classical sense, yet their presence can be measured through effects such as the Casimir force, a subtle attraction between metal plates caused by the fluctuating vacuum itself. It is a reminder that even nothing drifts with activity beneath the quiet horizon of space. Every known particle, quark, electron, photon, is a ripple in a quantum field. These fields stretch across the universe, connecting everything in a soft, invisible web. A particle exists wherever the field vibrates. It is not a tiny dot, but a localized excitement, a wave rising from an ocean that never stops moving. When the vibration fades, the particle vanishes. This fluid nature softens the idea of solidity. Reality becomes a dance of patterns drifting across cosmic waters. And yet, the more we study these fields, the more we wonder whether something deeper lies beneath them. String theory suggests that at the smallest scale, particles are not points but one-dimensional strings. Their tiny oscillations determine the identity of everything in the universe. A quark is one vibration. A photon is another. In this view, the universe is woven from vibrating threads floating in dimensions so small, they remain hidden from sight. The smallest part of reality becomes a note, a musical tone drifting beneath the structure of existence. Other theories paint an even more intricate picture. Loop quantum gravity proposes that space itself is quantized. Instead of being smooth, it is made of tiny loops connected in a vast network. Like the fibers of a cosmic tapestry, these loops are incredibly small, far smaller than quarks or string vibrations. They form the very geometry of reality. If this is true, then even space has a smallest unit, a pixel-like grain beneath everything. The smallest part of the universe might be the tiniest stitch in this quiet, woven fabric. The holographic principle adds another layer of wonder. It suggests that our three-dimensional reality may emerge from information encoded on a distant surface. Everything we experience, matter, motion, space, time, could drift from a two-dimensional boundary into the illusion of depth. In this model, the smallest element of the universe is not a particle, but a unit of information. A tiny bit in a cosmic script that writes itself across the horizon of space-time. Reality becomes a projection, a soft glow cast into existence by patterns we cannot see directly. Regardless of which model is closest to the truth, all point toward a profound idea. The universe becomes stranger, softer, and more dreamlike the deeper we look. The smallest scales are realms where particles float in multiple states at once, where waves drift through barriers, where empty space flickers with energy, and where reality bends into forms that challenge our understanding. Perhaps the smallest part of the universe is not something solid, but something dynamic, a process, a motion, a vibration that dances across the smallest canvas imaginable. It may be more like a whisper than a building block, more like a ripple than a stone. And in this quiet realization, the universe feels less like a machine and more like a vast living poem. Every particle is a syllable. Every field is a line. Every vibration is a verse drifting through the dim light of the cosmic dawn. As we continue deeper into this gentle frontier, the question does not vanish. It expands, softening into the calm rhythm of existence itself. As we descend even further into the hidden layers of reality, the sense of solidity dissolves completely. The universe at this scale does not behave like a structure built from bricks, but like a quiet pattern flowing beneath dim light. Each time we ask, what is the smallest? The answer floats a little farther away, softening at the edges, drifting into deeper calm. The journey inward becomes a meditation, a slow drift through a realm where boundaries fade and existence becomes a gentle rhythm. Quarks, once considered indivisible, behave like shimmering points that move through the strong force's restless sea. Gluons, the mediators of that force, constantly appear and vanish, creating a dynamic storm inside every proton and neutron. This storm is not violent, it is delicate, a swirling motion that floats and softens into countless rearrangements. Even the stability of matter depends on this dance. Without it, the particles that form our world would fall apart instantly. But when we zoom in further, the notion of position begins to weaken. A particle's exact location can never be fully known. Instead, it exists as a probability cloud, a soft haze that drifts across space. This cloud is not a physical mist, but a map of potential states. The particle may be here or there, or in several places simultaneously, until measurement collapses its possibilities into a single outcome. In this strange realm, the smallest part of the universe behaves not as a point but as a whisper of chance beneath a quiet horizon. This brings us to the Planck scale, the limit where our current understanding falters. At distances smaller than the Planck length, the smoothness of space breaks down. Time becomes grainy. Geometry twists. The equations that describe the universe lose clarity, as if the cosmos hides its deepest secrets behind a curtain of dim light. The smallest units here may resemble tiny loops, threads of geometry that form the foundation of space. They float, drift, and interlock in silence, creating the fabric through which particles later move. If loop quantum gravity is correct, space itself is made of these loops, woven into a vast network. Particles become the excitations of these loops. Motion becomes the shifting of their connections. Reality becomes a tapestry woven from tiny knots of existence. The smallest part of the universe then becomes a volume quantum, a grain of space so small that it defies the imagination. It is not matter. It is not energy. It is structure itself. But if string theory holds the deeper truth, then the smallest part is not a loop, but a vibration. Strings, thinner than any particle, vibrate across hidden dimensions. Their notes define what a particle is: a quark, a photon, a neutrino. The entire universe becomes a cosmic instrument, playing melodies that flow through space-time. Every object, every force, every atom arises from the music of these strings. In this view, the smallest part of the universe is a frequency, a pattern of oscillation drifting through the unseen. And if the holographic principle is correct, then the smallest part may be a unit of information, a tiny bit encoded on a cosmic boundary far beyond our field of view. Everything we experience inside the universe may be a projection from this boundary. Particles, stars, galaxies, even the flow of time may float outward from encoded patterns, unfolding like a soft glow cast onto the three-dimensional world. These possibilities, though different, share a poetic truth. The deeper we travel, the more reality transforms into something abstract and beautiful. Matter becomes vibration. Space becomes geometry. Existence becomes information. The universe reveals itself not as a structure built from tiny blocks, but as a sequence of gentle waves drifting through the deepest layers of reality. So what is the smallest part of the universe? It may be a loop, a string, a quantum, or a bit of information. Or it may be all of these at once, woven into the space where certainty softens into possibility. And as we float in this quiet frontier, wrapped in deeper calm, the question becomes less about finding a final answer and more about listening to the soft rhythm that echoes beneath everything. As we drift further into the quantum depths, the landscape of reality becomes ever more abstract, as if the universe itself begins to whisper rather than speak. At this level, objects lose their edges, distances lose their meaning, and time becomes a soft sequence of uncertain moments. The question of the smallest part becomes less about structure and more about behavior. A subtle choreography beneath dim light, shaped by invisible rhythms that float through the foundation of existence. Consider the concept of a field, one of the deepest ideas in modern physics. A field is not a substance or a particle, but a condition of space, a presence spread everywhere. An electron is not a tiny bead, but a ripple in the electron field. A photon is a ripple in the electromagnetic field. These ripples drift like gentle waves across a quiet horizon, appearing where energy is concentrated and fading when the disturbance settles. In this picture, the universe is not made of objects, but of events, excitations, ripples of influence. Even more delicate is the idea of symmetry. Symmetry governs how particles behave, how forces interact, and how the universe maintains order at its smallest scales. When symmetry breaks, new structures emerge, particles acquire mass, forces separate, and the early universe transforms from a glowing sea of simplicity into the rich, complex cosmos we now inhabit. These transitions soften the fabric of reality into new forms, guiding everything from atomic nuclei to galaxies. Beneath every particle lies a pattern of symmetry, like a quiet blueprint woven into the essence of existence. The search for the smallest part leads us into another possibility: the Planck foam. According to some theories, space-time itself undergoes violent fluctuations at the smallest scale. Space becomes frothy, swirling, constantly reshaping. Tiny bubbles appear and burst in an unimaginably rapid dance. These fluctuations do not resemble matter or energy, but raw geometry flickering beneath dim light. At this level, the smooth flow of space-time dissolves into a haze, a deeper calm where even direction and distance float into uncertainty. Loop quantum gravity builds on this idea. It proposes that space is composed of tiny loops woven into a network called a spin foam. These loops are the smallest units of volume. They drift and connect to form the architecture of space-time itself. Every movement, every particle, every moment is a shifting in this woven geometry. If this is true, then the smallest part of the universe is a quantum of space, a tiny loop that forms the foundation of everything above it. But string theory gives us another possible vision. Here, the smallest part is a vibrating filament of energy, a string that oscillates across hidden dimensions. Each mode of vibration creates a different particle. A single string may vibrate in countless harmonics, forming the entire spectrum of matter and forces. In this dreamlike picture, reality is not made of particles, but of melodies. Cosmic notes drifting through the fabric of space-time. These strings float beneath the quiet horizon of higher dimensions, too small to see, yet powerful enough to define the universe. And beyond these ideas lies the holographic principle. It tells us that everything inside the universe may be encoded on a distant surface. Every particle, every star, every thought could emerge from information written along a cosmic boundary. Reality becomes a projection, a soft glow cast from a deeper layer. In this view, the smallest part of the universe is a bit of information, a fundamental symbol from which the entire cosmos unfolds. Through all these theories, a pattern becomes clear. The deeper we search, the more the universe dissolves into structure rather than substance. The smallest parts are not tiny pebbles, but dynamic behaviors, vibrations, loops, ripples, information. They drift and float beneath existence, shaping all that we see. In this quiet frontier, the cosmos invites us to soften our expectations. The smallest pieces of reality are not solid. They are subtle, not rigid, but flexible, not objects, but whispers, moving with gentle waves through the deepest layers of space and time. As we drift deeper into this microscopic realm, the nature of smallest becomes harder to define. What we once imagined as tiny solid beads now appears as patterns, ripples, and fleeting events. The universe at its most fundamental level is not carved from matter, but woven from behaviors. A quiet interplay of fields and vibrations floating beneath a dim light that barely touches the limits of space and time. The more we explore, the more the idea of a smallest piece softens into a concept shaped by uncertainty. Quantum mechanics shows us that the world is built from probabilities. A particle does not have a precise location until we observe it. Instead, it spreads like a soft cloud, drifting through many possible places at once. Its behavior is guided by the wave function, a mathematical rhythm that moves with gentle waves across the canvas of existence. When we measure it, this hazy presence collapses into a single point. This collapse is not a physical shattering but a choice, one outcome settling out of countless possibilities floating beneath the quiet horizon of the quantum world. Even the forces that shape matter behave in dreamlike ways. The electromagnetic field carries light and binds atoms together. The strong force holds quarks inside protons and neutrons, gluing them with the help of gluons that flicker in and out of existence. The weak force allows particles to transform into other particles, drifting across identities in a process that happens deep inside stars and within the fabric of our own atoms. These forces are not built from smaller parts. They are fundamental interactions, whispered into being by the structure of the quantum fields that fill all of space. Below these fields, the notion of space itself begins to waver. At the Planck scale, space may be composed of discrete units. Each unit is a tiny quantum of volume, a grain of geometry. Time may tick forward in equally tiny increments. Movement becomes a sequence of jumps instead of a continuous flow. The idea of smoothness, the idea that we can divide space forever, fades into deeper calm. Beneath this threshold, reality may float in a foam-like texture, bubbling and twisting in patterns too rapid and too small for our minds to follow. Loop quantum gravity imagines this foam as a network of interconnected loops. Every point in space becomes a knot where loops meet. Every movement becomes a change in their arrangement. In this view, particles and fields emerge from the geometry of these loops, like ripples forming in a woven net, drifting beneath dim light. The smallest part of the universe becomes not a particle, but a tiny unit of geometry. A quantum of space. String theory offers a different melody. At the smallest level, everything becomes a vibration. Strings oscillate across dimensions beyond our senses. Their frequencies determine the identities of all particles. A quark is a string vibrating in one pattern, an electron in another. These strings float through the universe, stretching and twisting in silence, shaping all matter and energy. Here, the smallest part is a vibration, a note in the cosmic symphony. And then there is the holographic principle, suggesting that reality is a projection. If this is true, the smallest part of the universe is an informational pixel, encoded on a boundary far beyond our reach. Everything we see, touch, and feel floats into existence from this information, unfolding like a soft light projected into three-dimensional space. Our universe becomes a gentle curtain of symbols drifting in unison, each one shaping the world we inhabit. As our journey continues, the smallest building block becomes harder to grasp, not because it is too tiny, but because it may not be a thing at all. It may be emotion, a pattern, a whisper of energy vibrating beneath the structure of existence. The deeper we go, the more reality softens into mystery. The scale becomes so small that our imagination must float freely, guided by gentle waves of intuition. And through this deeper calm, the universe offers a quiet message. Perhaps the smallest part of everything is not something we can find, but something we can feel, a rhythm woven into the very heart of reality. As we continue descending into the smallest realms of the universe, a quiet realization begins to form. The deeper we look, the less the universe resembles a collection of tiny, solid pieces. Instead, everything begins to drift into abstraction, into soft patterns that float beneath our understanding. At these unimaginably small scales, reality behaves like a whisper, moving under dim light where shapes blur and boundaries soften. The search for the smallest part becomes a search for the deepest rhythm hidden beneath existence. One of the most fascinating clues comes from the behavior of particles known as leptons. Electrons, muons, tau particles, and their ghost-like cousins, neutrinos. Electrons orbit atoms not as small spheres, but as probability clouds drifting around the nucleus. They never sit in one place. They spread out, collapse, and spread again. They behave like gentle waves moving across the fabric of space-time. Even though electrons appear fundamental, their essence is still described not as a thing, but as a vibration in a quantum field. Neutrinos go further. They float through matter almost without interacting. Trillions pass through your body every second under the quiet horizon of the night sky, and you never feel them. They drift through Earth, through stars, through everything. Their near invisibility reminds us that the smallest pieces of reality may be far more ethereal than we imagine, like faint ripples born from distant events. Still, we push deeper. If electrons and quarks are not made of anything smaller that we can detect, perhaps the structure lies not in the particles themselves, but in the forces that govern them. The strong force binds quarks with such intensity that pulling them apart only creates more particles. The weak force allows transformations that shape nuclear reactions in stars. The electromagnetic force lights the cosmos. Gravity curves space itself. None of these forces are built from smaller pieces. They are woven into the fabric of fields, drifting and shifting in seamless harmony. But if the standard model describes these particles as fundamental, why does the universe feel like it hides more? Why do we sense that something even smaller waits beneath the surface? One possibility is the existence of prions, hypothetical building blocks, proposed to lie beneath quarks and leptons. Though unproven, they offer a way to explain patterns in particle behavior. These prons, if real, would be unimaginably small, drifting inside quarks like tiny vibrations hidden under deeper calm. They would float through layers of energy, so dense and subtle that no current experiment can detect them. Prone theories soften the boundaries of particle physics, suggesting that our understanding may be layered like the quiet spirals of a galaxy. Another possibility is that smallest does not refer to particles but to information. If the holographic principle is true, then the universe is built from bits, tiny units of encoded data. Particles, fields, forces, space, and time would all emerge from this cosmic information. The smallest piece, then, becomes a single bit in the universe's vast script. These bits drift along the edges of space-time, forming the blueprint from which our reality floats outward like a projection in dim light. As we approach the Planck scale, where quantum gravity reigns, the smoothness of space dissolves. Here, space-time may flicker like a restless sea of geometry. Some theories describe this region as a foam, tiny bubbles forming and collapsing, governed by fluctuations beyond our imagination. Space itself becomes fluid, shifting in gentle waves. At this scale, the universe is no longer made of objects at all, but of dynamic patterns that drift and soften into a haze beneath the quiet horizon of existence. And through this journey, a quiet truth reveals itself. The smallest part of the universe may not be something we uncover with a microscope, but something we understand with imagination, something that floats between mathematics and reality, something that lives as a rhythm rather than a thing. As we drift through these layers, wrapped in deeper calm, the question changes shape. The smallest part of the universe may be a vibration, a loop, a grain of space-time, or a whisper of information. Or perhaps it is all of these at once, woven together into the subtle heartbeat of the cosmos. As we go deeper into this invisible landscape, the meaning of smallest continues to drift away from anything solid. The universe at these scales behaves like a soft vibration moving under dim light, a delicate shimmer that floats beyond our familiar sense of structure. What we once imagined as tiny marbles now appears as fragile patterns, shifting fields, and subtle movements that soften into uncertainty. Every step inward brings us closer to a realm where reality feels more like a dream than a machine. At the heart of quantum theory lies the idea that particles are excitations in fields. These fields stretch across all of space, reaching from one edge of the universe to the other. When a particle appears, it's not because a tiny object has entered the world. It's because the field has rippled, risen, and momentarily concentrated its energy into a detectable disturbance. This idea gently replaces the traditional notion of smallest parts. There may be no pieces at all, only waves drifting through deeper calm. But even waves can behave in strange and intricate ways. A single particle can act as if it takes multiple paths at once. It can float through barriers as though they are soft and permeable. It can drift into superposition, existing in several states simultaneously. These behaviors reveal that the smallest scales of the universe are not rigid but fluid, shaped by mathematics, governed by probability, and illuminated only dimly by our experiments. As we move further inward, we reach the realm of the Planck scale. This region is so small that our words begin to fail. Here, space-time may be grainy. Each grain is unimaginably tiny, far smaller than a quark or electron. These grains do not exist in space. They are space. They form the quiet horizon upon which all motion unfolds. If we try to look smaller than this, our understanding dissolves. Distances lose meaning. Time itself may float in tiny increments, ticking forward in quantum steps rather than a smooth flow. Some theories describe this region as a froth, a wild foam where space bubbles and fluctuates. At this level, the universe drifts between shapes, twisting in ways that defy intuition. Yet even in this chaos, there is order, a deeper calm. Each bubble of the foam may represent a tiny quantum of geometry, a unit of space-time that cannot be divided further. If this is true, then the smallest part of the universe is a moment of space, a breath of time, a single grain in the cosmic weave. String theory offers a different view. In this idea, the smallest part is not a grain or a particle, but a vibration. These strings are unimaginably small loops or strands that vibrate in multiple dimensions. Their vibrations determine everything: mass, energy, the forces of nature. A quark is one vibration. A photon is another. In this soft, dreamlike picture, the universe becomes an instrument playing a quiet melody beneath dim light, with each note floating into reality as a particle. And then there is the idea that the foundation of reality is not material, but informational. According to this perspective, the smallest unit of existence may be a bit. A tiny yes or no, encoded in the structure of space-time. These bits drift across a cosmic boundary, forming the holographic blueprint from which everything we observe emerges. If so, the universe is not a collection of parts, but a flow of information, softening into the world we see like gentle waves moving across a silent shore. Every one of these possibilities points to the same quiet truth. As we descend into the smallest layers of existence, the universe becomes less like a solid object and more like a pattern, a rhythm, a whisper moving beneath creation. The smallest part may not be something we can hold or even imagine clearly. It may be a vibration, a loop, a grain of geometry, a packet of information, a ripple in a field, drifting beneath deeper calm. And within this realization, the universe begins to look not like a structure, but like a poem, soft, subtle, infinite in its layers, written in the quiet language of quantum motion. As we drift further inward, the universe becomes a place where definitions soften and boundaries blur. At these scales, the solid idea of a smallest part dissolves and floats away like a fading echo beneath dim light. What remains is a landscape shaped not by objects, but by behaviors, tiny vibrations, sudden flickers, gentle waves of probability drifting quietly through the cosmic fabric. Quantum mechanics teaches us that particles are not tiny stones or specks. They are excitations in fields, rising and falling like soft ripples on an invisible ocean. When an electron exists in an atom, it does not move along a clear path. Instead, it occupies a cloud-like region, a haze of possibility drifting around the nucleus. This cloud is defined by the wave function, a mathematical whisper describing where the electron might be found. It does not commit to a location until observed. The moment of measurement collapses this soft cloud into a single outcome, like a gentle wave settling beneath a quiet horizon. Even more enigmatic is the behavior of quarks, the building blocks of protons and neutrons. They are so deeply confined by the strong force that we can never see one alone. They swirl inside protons in a chaotic blur of color charge, interacting through gluons that flicker constantly. This swirling sea of quarks and gluons is called the quantum chromodynamic vacuum, and it floats beneath the familiar world like a restless heartbeat. The smallest parts of the universe hide within these deep motions, never still, never entirely visible. Yet, as we try to peer below quarks, our understanding softens again. Some theories propose that quarks may be made of even smaller components, prons. These hypothetical entities float within quarks, forming the structure of the particles we know. If prons exist, they would be unimaginably tiny, drifting through fields we cannot detect, carrying the properties that define the particles of the standard model. But without experimental evidence, they remain dreamlike ideas, drifting at the edge of scientific imagination. Below this lies the Planck scale, a boundary where our equations falter. At this scale, space-time may tremble and boil. Distances lose meaning. Time becomes grainy. The geometry of the universe flickers in a foam-like texture called Planck foam. In this foam, space itself might be composed of tiny units, minuscule volumes woven together in countless shifting patterns. These loops of space-time float at the foundation of everything, forming a lattice too small to see, too fundamental to ignore. If this is true, the smallest part of the universe is a quantum of space itself. Meanwhile, string theory suggests another vision. Instead of being made of particles, the universe may be woven from vibrating strings. These strings can stretch, twist, or form closed loops. Their vibrations determine the properties of particles: mass, charge, spin. Every particle becomes a note, a tiny song drifting through hidden dimensions. These dimensions, though unseen, fold and curl around the strings, shaping the melody of existence. In this view, the smallest part of the universe is not a particle, but a vibration, a soft rhythm floating beneath dim light. And beyond strings lies information itself. The holographic principle proposes that everything inside the universe may be encoded on a distant surface. Each particle, each force, each moment may drift from this cosmic boundary into the space we experience. If this idea is correct, the smallest part of the universe is a pixel of information, a fundamental bit woven into the fabric of reality. In this picture, the universe becomes a projection, drifting outward like gentle waves unfolding across the night sky. Through all these layers, fields, quarks, strings, loops, information, one truth becomes clear. The deeper we explore, the more reality slips from the grasp of concrete objects and into something fluid, soft, and dreamlike. Soft and dreamlike. The smallest part of the universe may be a rhythm rather than a thing, a whisper rather than a stone. And as we float in this quiet frontier, wrapped in deeper calm, the question becomes not what smallest piece, but what patterns drift beneath the surface of everything. As we continue drifting into the tiny, trembling heart of reality, the universe begins to feel less like a structure and more like a mood, soft, elusive, shaped by patterns that float beneath understanding. At these scales, everything moves with gentle uncertainty. Nothing stays still. Nothing holds a clear boundary. The smallest layers of existence behave like whispers drifting under dim light, shimmering for an instant, and then fading into deeper calm. Quantum field theory tells us that every particle we see, electrons, quarks, photons, is a ripple in an underlying field spread across the universe. These fields do not turn on or off. They are always present, quietly vibrating, waiting for the right conditions to form a particle. When energy concentrates in a field, a particle appears. When the energy disperses, the particle disappears. There is no smallest bead, only temporary excitations floating through an endless, invisible ocean. Beneath this ocean lies the Heisenberg uncertainty principle, a rule that softens the certainty of all motion. It tells us that the more precisely we know a particle's location, the less precisely we can know its momentum. This principle is not a limitation of our instruments. It is woven into the nature of reality. Particles drift through possible states, floating between locations until observation forces them into a single outcome. At these scales, existence becomes a haze, like gentle waves sliding across a quiet horizon. Within atoms, particles behave in ways that defy our everyday intuition. Electrons do not orbit like planets around a star. They form shapes around the nucleus, clouds, shells, shimmering distributions of probability. These clouds shift depending on energy levels, transforming into new patterns as electrons absorb or release energy. These shapes are not objects but mathematical descriptions of where the electron might drift. The smallest pieces of matter behave more like melodies than marbles. Inside protons and neutrons, quarks and gluons dance in a frantic storm. Gluons constantly appear and vanish, binding quarks with a force so strong it grows with distance. Because of this, quarks can never be seen on their own. They remain confined within particles, flickering in and out of arrangements so fast that the very idea of a fixed location becomes meaningless. Even so, this turbulent sea softens into stability at larger scales. forming the matter that builds stars, planets, and people. But deeper possibilities await. Some theories propose prions, hypothetical particles even smaller than quarks. These prions would drift as the true building blocks of the standard model. They would be so small, so delicate, that they could float inside a quark the way a quark floats inside a proton. If real, prions would represent a new layer, a subtle foundation beneath the chaotic world of quarks. But for now, they remain a gentle speculation, drifting at the edges of experimental possibility. Then we return again to the Planck scale, a realm so tiny that our best theories unravel. At this scale, space-time may not be smooth but granular, composed of tiny units of area and volume. These units jitter, bubble, and twist in a phenomenon called quantum foam. Space itself becomes unstable, shifting like water under moonlight. Distances become uncertain, directions soften. Time floats in discrete steps, like frames flickering in a cosmic film. If space truly has these grains, they are the tiniest elements of the universe, not particles, but moments of geometry. String theory offers its own soft explanation. Strings vibrate across dimensions, creating the particles we observe. Their oscillations determine everything: mass, charge, spin. A quark is not a bead, it is a vibration. A photon is not a dot, it is a ripple. These strings, smaller than anything we can measure, drift through hidden dimensions curled so tightly they escape detection. If this view is correct, the smallest part of the universe is a pattern of vibration, a tone in the cosmic symphony. And beyond strings lies the possibility of pure information. The holographic principle suggests that reality emerges from encoded bits of data on a distant boundary. Each particle, each field, each moment may float out of these informational patterns, like a soft projection spreading across the night sky. In this worldview, the smallest unit is an informational pixel, a single bit woven into the cosmic code. Through all these layers, a quiet truth reveals itself. The universe becomes more abstract, more dreamlike. The deeper we travel, reality softens into rhythms. Particles drift into waves. Space floats into geometry. Information shimmers beneath dim light. The smallest part of the universe is not a tiny object, but a beautiful idea. A whisper, a vibration, a pattern drifting beneath the quiet horizon of existence. As we travel deeper into the hidden architecture of existence, the universe begins to resemble a soft mirage. Shapes lose their edges, distances shrink into abstraction, and time itself drifts into a slowed rhythm. The question of what is the smallest part of the universe becomes harder to ask, because the closer we look, the more reality seems to float away from concrete form. It becomes a delicate tapestry woven from waves, vibrations, and invisible geometries under dim light. At the scale of atoms, the structure already feels ethereal. Electrons occupy clouds rather than orbits, drifting through regions defined by probability rather than certainty. These clouds expand and contract as electrons shift between energy levels, forming quiet patterns that resemble petals, shells, and ripples around the nucleus. The atom is not a small solar system. It is a soft haze, shaped by the motion of fields rather than the paths of particles. Inside the nucleus, protons and neutrons hold their own mysteries. They are built from quarks bound together by gluons, but the space inside them is not empty. Instead, it is filled with a restless sea of virtual particles, quarks flickering in and out of existence, gluons exchanging momentum, fields vibrating in chaotic harmony. The boundaries inside a proton soften into turbulence, with quarks floating in constant motion, drifting through a domain where the strong force dominates everything. This sea behaves like a storm hidden beneath a quiet horizon, invisible yet essential. Yet, even within this swirling chaos, questions remain. Are quarks truly fundamental? Or are they made of something smaller, something even more delicate? Prion theories gently suggest that quarks and leptons might themselves be composite objects. If prions exist, they would be so small, so deeply hidden, that they would drift below the threshold of any known experiment, floating in a realm far beyond our technological reach. Their presence would soften our understanding of fundamental and introduce a new layer beneath the standard model. But the most profound shift comes when we move below the level of particles entirely. Quantum field theory tells us that the world is not made of objects, but of fields. These fields fill all of space, extending infinitely in every direction. A particle is simply a temporary excitation in a field, a wave rising, floating, and then fading back into calm. When the wave collapses, the particle disappears, but the field remains. The universe becomes an ocean of possible excitations, shaped by the gentle waves that drift through it. Yet even fields may not be the final layer. At the Planck scale, space-time itself may no longer be smooth. Instead, it may be quantized, broken into tiny units of volume. This gives rise to the idea of quantum foam, a bubbling, flickering structure where space-time twists into spontaneous shapes. These fluctuations happen at absurdly small scales, far beyond atoms or particles. If this foam is real, the smallest part of the universe is a grain of geometry, a tiny loop, a quantum of space floating inside a cosmic network. String theory paints another picture. Strings, impossibly tiny, vibrate across multiple dimensions. Their vibrations create all particles and forces. A quark is one vibration, an electron another. These strings float beneath our world, stretching and contracting like quiet notes in a cosmic melody. They are not located in ordinary space, they create space. In this view, the smallest part of the universe is a pattern, a rhythm, a movement too small to be seen but powerful enough to shape everything we experience. Then comes the holographic principle, whispering that reality itself might be encoded on a distant boundary, that our three-dimensional universe floats outward from a two-dimensional surface like a soft projection. If so, the smallest part of the universe is not a particle, not a string, not a loop, but a bit of information, a single unit of encoded reality. These bits drift across a cosmic horizon, forming the blueprint of all matter and energy. Through these layers, one gentle truth emerges. The universe becomes more abstract the deeper we look. The smallest pieces dissolve into waves, loops, vibrations, and data. They drift beneath dim light, soften into uncertainty, and float through deeper calm. The smallest part of the universe may not be a thing at all. It may be a relationship, a vibration, a possibility, a whisper of information woven into the quiet horizon of space-time. As we drift even further inward, the universe begins to feel less like something built and more like something performed. A quiet choreography taking place beneath dim light, where each movement softens into the next. At this depth, the notion of a smallest part no longer feels solid. Instead, it floats like a thought on the edge of sleep, changing shape each time we try to hold it still. The deeper we look, the more existence becomes a rhythm moving through deeper calm. On the quantum level, particles defy expectations. They emerge from fields, vanish back into them, and reappear in different forms. An electron does not travel from one point to another like a tiny stone. It flickers between potential paths, drifting through a haze of possibilities. Its position, momentum, and behavior are guided by wave functions, mathematical patterns that float through space-time like gentle waves spreading across a quiet horizon. The electron becomes less a particle and more a probability that shimmers into being when observed. Inside protons and neutrons, the story becomes even more intricate. Quarks and gluons fill the space with constant fluctuations, forming a restless dance known as the quantum chromodynamic C.L. Gluons leap between quarks, binding them with a force so powerful it cannot be overcome. Virtual quarks appear and vanish in the blink of an instant, drifting through the proton's interior with unpredictable patterns. Nothing is ever still. Nothing is ever simple. The smallest pieces of matter exist in a blur of motion, softened by uncertainty and shaped by fields we cannot see. Yet this quantum restlessness is only the beginning. If we move deeper than quarks, theoretical layers begin to unfold. Prone models suggest that quarks and leptons might be made of even smaller constituents, tiny entities woven from energy patterns too faint to detect. These prawns, if they exist, would float beneath the stability of known particles, forming delicate substructures that drift through dimensions inaccessible to current experiments. They remain hypothetical, but their existence would shift our view of the universe into an even finer level of detail. And then comes the realm where space itself begins to unravel. The Planck scale marks a boundary where the smoothness of space-time dissolves. Below this, distance and time no longer behave in continuous form. Instead, space-time may be composed of tiny units, granular, discrete, woven from loops of quantum geometry. These loops form the fabric of space, creating a network that vibrates with energy. Motion becomes the shifting of these connections. The smallest part of the universe becomes a quantum of volume, a minuscule piece of geometry that floats within a vast cosmic lattice. But if string theory is right, even these loops are not fundamental. Instead, reality might be made of tiny vibrating strings. These strings are not embedded in space. They create space. Every vibration corresponds to a particle. A quark is one note, a neutrino another, a photon yet another. Strings drift through multiple dimensions, curled so tightly they remain unseen. Their oscillations play the melody of existence, shaping matter and light with a softness that feels almost musical. Here, the smallest part of the universe becomes a vibration, a tone drifting beneath dim light. And beyond even that lies the idea that the universe is information. According to the holographic principle, everything that happens inside the universe may be encoded on a distant cosmic boundary. Each particle, each atom, each moment in time arises from these encoded bits. Space-time itself floats outward as an emergent phenomenon. In this picture, the smallest part of the universe is an information pixel, a tiny fragment of the cosmic code. What we perceive as particles and forces are simply patterns projected into our three-dimensional reality, like soft light spreading across a screen. Each theory offers a different answer. Each answer drifts into the next, and each one softens our understanding of what smallest means. At the deepest layers, the universe becomes a field of possibilities rather than objects. It becomes a ballet of energy rather than a stack of bricks. It becomes a quiet symphony of vibrations, loops, and information, floating beneath the quiet horizon of reality, wrapped in deeper calm. The smallest part of the universe may not be a particle, but a whisper, a subtle movement, a tiny vibration, a grain of geometry, a bit of encoded existence drifting beneath the dim light of the cosmic unknown.